Bismillahirrahmanirrahim. This video contains some basic concepts on electrostatics, unit number 13, Physics 10 National Book Foundation, as well as conceptual questions from question number 5 to question number 10. We start with some basic concepts of electrostatics. Charge is the very basic property of matter. Matter is composed of atoms that contain both positive and negative charges. There are two types of charges present in any object. Protons, the positive charged particles, are contained in the nucleus and cannot move freely within or across different objects. Electrons, on the other hand, are negatively charged, are very light mass, are free to move across matter within an object or across different objects. Mass of one proton is equal to 1.673 into 10 power minus 27 kgs. Mass of one electron is 9.109 into 10 power minus 31 kg. Notice the mass of electron is very smaller than the mass of proton. It's 10 power minus 31, whereas proton is 10 power minus 27. Note that the mass of one proton is approximately equal to the mass of 1837 electrons. I said 1837 electrons make up the mass of one proton. Charge on one proton is positive 1.6 into 10 power minus 19 coulombs. Charge on one electron is negative 1.6 into 10 power minus 19 coulombs. Note, electrostatics deals with charges at rest. What is a dipole? An object having two poles is a dipole. An electric dipole is formed when two charges, positive and negative, form concentration on two opposite ends of any object due to presence of some charge near the object or in the presence of an electric field. Now here I have tried to show a dipole. This is an object which has concentration of positive charges on one end and the concentration of negative charges on the other hand. A dipole is somewhat an object looking like this. A magnet is a dipole since it has two poles, north and south poles. Question 5. If the charge on 2-point charges is doubled and the distance between them is halved, what will happen to the magnitude of the force? What will be the new force if the existing force is 10 Newton? Now first the key point. Increasing the charge increases the force and reducing the distance also increases the force by square of the new decreased distance. Now doubling the two charges means an increase of 2 by 2 equal to 4 times and square of half the distance again is an increase by 4 times. 4 times increase result in 4 into 4 equal to 16 times increase in force. The answer starts here. The electrostatic force between 2-point charges Q1 and Q2 placed at a distance r is given as F is equal to K Q1 Q2 divided by r square. Mark it as equation number 1. With the double values of charges, that is 2q1 and 2q2, and the distance reduced to half, that is r becomes r by 2, the new force F dash should be written by substituting the values. Now, substituting the doubled values of 2q1 and 2q2 and half the value of r, that is r by 2, results in f dash equal to k, the constant of proportionality, 2q1, 2q2 divided by r by 2 square. Now multiply the 2's in the numerator and square the denominator, results in f dash equal to k 4q1 q2 divided by r square by 4. Now rewrite the complex fraction with the division sign as f dash equal to 4k q1 q2 divided by r square by 4. Now resolve the division of the fraction to multiplication, that is f dash is equal to 4 k q1 q2 multiplied by 4 divided by r square. This is reciprocal of this quantity, changing the division sign to multiplication. Now multiply the two 4's to result in 16 and rewrite it as f dash equal to 16 k q1 q2 divided by r square. Now, as k q1 q2 over r square was given in equation 1 equal to f, so replace f for k q1 q2 over r square from equation 1 and write it as f dash equal to 16 f. Now, since the value of F was given as 10 Newton, substitute existing force F is equal to 10 Newton, and that results in F dash equal to 16 multiplied by 10. The new force F dash becomes F dash equal to 160 Newton. Question 6. A 100 coulomb charge body of mass 20 kg repels 1 coulomb charge body of 10 grams with a force of 2000 Newton. Will smaller charge body apply force, same, smaller, greater force on 20 kg body? The key point. 1. Recall that force is an agent that changes or tends to change the existing state of a body. In this case, the 10 gram body may tend to change the state of 20 kg body. Second, the electrostatic force, attractive or repulsive, act on both the charge bodies equally. Now this problem can better be illustrated here. This is a 20 kg charge body with a 100 coulomb charge on it and a 10 gram charge body with 1 coulomb charge on it. As stated in the problem, the 20 kg charge body with 100 coulomb charge exerts a force of 2000 Newton repulsive force on the 10 gram body. At the same time, the 10 gram body will also exert a force of 2000 Newton on the 20 kg charge body in the opposite direction. The answer starts here. The electrostatic force, repulsive or attractive, act on both the charge bodies involved equally. Therefore, the 10 gram body will exert the same amount of repulsive force, that is 2000 Newton on 20 kg body. It would be very good if you can draw this figure and label it as given here to explain your answer better. Question 7. Why is it dangerous to hold long steel pipe or long steel pole upright during lightning weather conditions? The key points. Lightning weather means very huge amount of charge present on clouds or the suspended droplets. And number two is the moist atmosphere act as conductor and becomes the path for the static charges to flow to the ground. The answer starts here. Holding a long steel pipe or pole upright in lightning weather conditions may attract the charges to flow to the ground through the pipe or the pole held upright. This might cause the worker to be electrocuted and may cause severe or fatal injury. Question 8. The capacitance of a capacitor is equal to the ratio between the charge stored and the potential difference between its plates. Does the value of capacitance depend upon the amount of charge and the potential difference? The key point. The capacitance of a capacitor is a constant of proportionality. C is equal to Q over V. It's a proportion between the charge and the voltage. Taken from the equation Q is equal to CV. Its value remains same since amount of charge Q changes proportionally as the change in the voltage V across the capacitor. The answer. No, the value of capacitor C does not depend on the amount of charge and the potential difference. Since Q is directly proportional to V, if the potential difference V is increased or decreased, it will increase or decrease the charge Q as well in the same proportion, hence keeping the capacitance C constant. So Q over V is equal to C is a constant. Question 9. Do two capacitors of different plate area gain same or different amount of charge if connected with the same battery? The key point. Capacitance of a capacitor means its capacity to hold amount of charge due to its physical geometrical shape, size, dielectrics used, and the distance between its plates or layers. The answer. The two capacitors with different plate area means different capacitance, hence both will gain different amount of charge. Physical factors affecting capacitance are 1. Area and geometry of plate, 2. Dielectrics used between plates, 3. Distance between the plates. Thus, capacitor with large plate area will have more amount of charge as compared to the capacitor with small plate area. Question 10. You have a device with capacitance of 250 nanocoulomb. Task is to decrease the capacitance of the device by connecting another capacitor with it such that the net capacitance of the combination is reduced to 50 nanocoulombs. Key point. The series combination of two or more capacitors reduces the net capacitance to less than any of the capacitors used. For capacitors in series, the equivalent capacitance is given as 1 over C equivalent is equal to 1 over C1 plus 1 over C2. This is for the two capacitors involved. Required net capacitance C equivalent is given as 50 nanocoulomb in our problem. One of the given capacitance is C1 is equal to 250 nanocoulomb. That is given here. You have a device with capacitance of 250 nanocoulomb. Now substitute these values in above equation to result in 1 over 50 is equal to 1 over 250 plus 1 over C2. Now move 1 over 250 to the other side. It results in 1 over 50 minus 1 over 250 equal to 1 over C2. Note that LCM is equal to 250. Remember, from any two numbers, the LCM is the greater number if it is a multiple of the smaller number as well. Since 250 here is a multiple of 50, therefore the least common multiple of the two numbers is 250. Now taking the LCM 250 and resolving this left hand side of the equation above results in 5 minus 1 in the numerator. Solving the numerator results in 4 divided by 250. This is equal to 1 over C2. Now cross multiply and simplify the numbers here. This will result in C2 equal to 62.5 nanocoulombs.